Hello everyone. Welcome to the solution of LeetCode problem 449 named Serialize and Deserialize a binary search tree. Here, serialization is converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across the network connection link to be reconstructed later in the same or another computer environment. Now we have to design an algorithm to serialize and deserialize a binary search tree. There is no restriction on how you serialize or deserialize the tree or how the algorithm should work. You need to ensure that a binary search tree can be serialized into a string, and this string can be deserialized to the original tree structure. Now, the encoded string should be as compact as possible. So, in short, we can say that we are given a binary search tree and we have to make this tree serialized and deserialized to solve this problem. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, let's take this example. Here the root is 2, which has two children, 1 and 3. This is a binary search tree and we have to perform the serialization and deserialization algorithm on this tree. Now let's see how can we solve this problem. So here basically we will use the depth first search algorithm to solve this problem. Initially the DFS algorithm will be in the top, which is 2. Now from the 2 we will go to its left children, which is 1. Now this 1 does not have any of the left or right children, or we can say that both of its children is null. So from 1 the call will be its left children and it is null, so it will return the value null. And again from 1 we will go to the its right children, and as it is null, so it is also returning the value null. Now 1 will return the value which is the value itself, which is 1, and the value coming from the left subtree, which is and the value coming from the right subtree, which is and. Similarly, from the node 2, the DFS call will be in this node 3, and it does not have any of the left or right children. So the left children similarly will return n, and the right children will return n. And the value 3 or the node 3 will return the value 3 and n. So here, so far, one of the left children of 2 is returning 1 and n, and the right children is returning 3 and n. So the value 2 will return 2 plus left children value, which is 1 and n, and right children value, which is 3 and n. Okay, now this is the compressed version or the serialized version of this binary tree or binary search tree. Now our task is we have to convert this serialized version into the valid binary search tree. Now the question is how basically we're gonna convert them. So here the algorithm is pretty simple. We have to take the advantage of C++ string stream class. So here in the string stream class, we have to consider each of the character of this as a word. So we have to make a space, which is 2 space, 1 space, then n space, then n space, then 3, then n, and so on. Now, as we are using a space between the characters, these individual characters will consider as an individual word in the string stream. So now let's iterate the string. At first we are at this node 2. So here we have to make a node by using this value 2. Now we are at this value 1. So we have to make the left node by using 1 here. And after that, we are encountering 2 of the end. So we don't have to take consideration it. Now we are taking another 3. So we have to make a node by using the 3 and make it a right children. So here we can see that this tree is the converted binary search tree version of this serialized string. And overall time complexity of this algorithm is big O of n, and overall space complexity of this algorithm is also big O of n. I hope you understood the algorithm. Now let's move on to the code. Here we are given a function named Serialize, which has a tree as a parameter. Now we have to return, if the root is null, we have to return space plus null. Otherwise, we have to return a space plus the value of the root plus recursively calling the serialize function into the left and right subtree. And in the deserialize function, we are considering a string data as the parameter, and we have to take the advantage of the string stream classes in C++. So here we are converting this string to the string stream classes, which is SS, and we recursively call a build tree function in this string stream formation of the given data. Now inside the build tree function, for each of the word, if the current word is null, we have to simply return null. Otherwise, we have to make the current word to a tree node by convert this string word into an integer. And finally, we have to recursively call the build tree function into the node's left subtree and into the right subtree. Finally, we have to return the node. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.